Hi guys, welcome back. Now, as promised, I will show you how electricity is generated and how can we use it.
Electricity and magnetism, they sort of go hand in hand. Where you find one, you find the other. So although this is an electrical circuit, there'll also be a magnetic field that's been created around this coil. And if I now introduce a second magnetic field by way of magnets, one should repel the other. And let's give it a little push.
With the copper coil turned into an electromagnet, each side repels and then attracts the permanent magnet underneath, forcing the coil to spin.
And just like that, you can create an electrical motor, and actually you can reverse it to not consume electricity, but to generate electricity. And here is an image how that can be done, so please have a look. So you are manually rotating magnets inside. Those magnets interact with copper wire, thus generating electricity. In this example, electricity is being consumed by this light bulb, but you can also store it in a battery. Before going to Minecraft, please have a look at this video, and that's it, we can proceed.
If we look inside a slice of copper cable at the free electrons surrounding the nucleus of the copper atom, you'll see that the free electrons are able to move to other atoms, but this happens randomly in any direction. If we then connect the slice of copper cable to a closed circuit with a power source, such as a battery, then the voltage will force the electrons to move, and these will then all flow in the same direction to try and get back to the other terminal of the battery. When I say circuit, this just means the route which electrons can flow along between the two terminals, the positive and the negative, of a power source. So we can add things into their path like light bulbs, and this means that the electrons will have to pass through this in order to get to the other terminal, and so we can use this to create things such as light. The circuit can even be open or closed. In a closed circuit, that means the electrons can flow around, and in an open circuit, this means that the electrons are not able to flow.
In this case, LED light is our redstone lamp, and by opening and closing a circuit, we are using a lever in Minecraft. And instead of copper wire, we are using redstone dust. And when we say 1 or 0, we mean closed circuit or open circuit. So no electricity or there is electricity. In the previous episode, we ended here. So now you see similarity with real world. And also now you know how you can use these on or off states to represent numbers. And if you want to represent bigger numbers, you just need more lamps and more levers, right? So let's do that. Let's do some numbers and I will show you some other stuff. So finally, we are back here. Back to square one. I showed you redstone, bases, electricity, and on, off states, how we can manipulate this binary digit, or also known as bit, to represent some numbers. Let's use this knowledge here. Before representing more numbers or letters, let's clarify one thing. This order, starting from small numbers to big numbers, is called little endian, and reversed is called big endian. So little when we have on the right side small numbers, and big endian when we have big numbers on the right. Either way is correct. We can use big endian, little endian, does not matter. For the next examples, I will use big endian. It might confuse you because for the basis I explained using little endian, so bear with me. Okay, I will use big endian as explained. Let's practice with some numbers. Please download this map if you want to, and try this by yourself. So let's try number 9. 8 plus 1 is 9. So in this system, big endian, it's 1, 0, 0, 1, then 4 trailing zeros. Let's do another number. Let's do 129. So it's 128 plus 1, 129. So 1, 0, 0, 0, 0, 0, 0, 1. Now think of any number and try it by yourself. Pause video here. Let's do, I don't know, 23. So 16 plus 4 is 20, 22, and 23. I hope it's clear. Now let's move to negative numbers. How do we represent negative numbers? We will lose 1 bit, so here we have 8 bits. And in computer science, 8 bits is a byte. And we lose 1 bit because it will represent if the number is negative or positive. So if this is on, this is negative. So let's do negative 5. 4 plus 1 is 5. And if we turn this on, it's negative number. So minus 5. So we have 8 bits here, but 1 bit is lost due to the fact that it's used for sign bit. As a sign bit, I mean. So total could be maximum of minus 127 or 127. If we represent only positive numbers, we can get up to 255 by using 8 lamps or 8 bits or 1 byte. Now let's move to letters. We can either say English alphabet has 26 letters, so we need a total of, let's say, 5 lamps, because this will get up to 31. So if we want to do letter Z, which is 26, it will be this. So 2 plus 8 is 10, plus 16 is 26. Now what if you want to represent also symbols like exclamation mark, dot, comma, and so on? You might have heard of ASCII table, and it's represented in different bases. In this case it's 8, hexadecimal is 16, decimal is 10. So ASCII stands for American Standard Code for Information Interchange. Simply said, it's a table representing letters, numbers, and symbols, and special characters. As you can see, we have 128 of them, so delete key on your keyboard has this code 127, null, which is nothing, means 0, then this is start of header, which basically means start of a file. This is start of textual file, if I'm not wrong. Here is our exclamation mark. Here is our capital H and lowercase I that we will show now in Minecraft. So hi. And yeah, that's kind of it. But also you can see we can represent the same thing in hexadecimal set, octal set. We are using decimal set now. Imagine here is the table. This is the first row. This is the second row. This is third, and so on. So in that table, letter H is here and letter I is here. So this is 72, this is 105. So we have 127 total. How many lamps do we need to represent them? We need 7 lamps because, look, 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 is 127 total. So to represent letter H, we need 72, and 72 is 8 plus 64. To represent lowercase I is 105. We turn these lamps on. So 1 plus 8 is 9, plus 32, let me think, 41, and 41 plus 64 is 105. So we have capital letter H, lowercase I. So hi. So to represent 2 letters or 1 word, in this case hi, we need 2 sets of 7 bits. But computers don't work very well with number 7, like with 7 bits. Yes, the computers back in the day, they used this table using 7 bits, but modern computers stopped doing that. They start using 8 bits because of this. Look. 8 is more natural because it's, you can be divided by 2, so you can achieve this number as the power of 2 again. At the beginning of the episode, we spoke about electricity and how redstone dust mimics it. It's basically a copper wire, then a power source could be a battery or electricity generated by your hand. But notice there is no minus or plus charge, so Minecraft does not have that. There's only signal or no signal. And actually it simplifies things, we don't need to think about that. And remember talking about opening or closing a circuit by using a lever on that scheme. Here is it in Minecraft. So we open the circuit, close the circuit, and the redstone lamp acts as an LED. So we allow the current to flow, we don't allow the current to flow. As you can see, Minecraft mimics real-life electricity. That's why we can build computers inside Minecraft. And to represent numbers, we use redstone lamps. We can do also negative numbers, and also letters and symbols. And that's it for this episode. Now you know how computers represent numbers, letters, negative numbers. In the next episode, we will do Boolean algebra. Don't worry, it won't be theory, it will be mostly practice. And you can already use them to replicate some of the mumbo jumbo videos and some other redstone contraptions. See you next time!